Before the ground breaks, something else sometimes happens. Something people rarely talk about. The sky glows, not lightning, not auroras, not reflections from cities. A soft, eerie light appears near the horizon. Blue, white, purple, sometimes green. It lasts seconds, sometimes minutes, and then the Earth begins to move. For centuries, these lights were dismissed as imagination. Stories told by frightened villagers. Strange tales recorded in journals, ignored by science, until cameras started capturing them. Earthquake lights, often called EQLs, have been reported before, during, and after major seismic events across the world. In 2009, before a devastating earthquake struck L'Aquila, Italy, witnesses reported glowing orbs hovering near the mountains. Days later, the ground ruptured. In 2017, during the Puebla earthquake in Mexico, security cameras recorded bright flashes. In Japan, glowing sheets of light were filmed during massive tremors. These weren't storms. Radar showed clear skies, no thunder followed, and yet light appeared where light should not exist. For a long time, scientists didn't know what to do with these reports. Earthquakes happen underground. Light happens in the sky. The two were not supposed to meet. But the reports kept coming. And the footage kept improving. High-definition cameras, dash cams, smartphones, security systems. The same phenomenon, again and again. A glow, a flash, a shimmer. Always tied to seismic stress. The question was no longer whether earthquake lights were real. The question became, what kind of force could bend the sky before breaking the Earth? To understand that, we have to go far below the surface, deep into the crust, into the rocks themselves, because rock is not as dead as it looks. Under extreme pressure, certain rocks behave in ways that feel almost alive. Granite, basalt, quartz-rich formations. When these materials are stressed, twisted, compressed, bent, their internal structure changes. Atoms shift. Electrons move. The rock becomes electrically active. Laboratory experiments have shown this clearly. When pressure is applied to certain rocks, they release electrical charges, not metaphorically, literally. Electric currents travel through the crust searching for release, and when they reach the surface, they escape into the air. That release can ionize the atmosphere, stripping electrons from air molecules. And ionized air glows, just like neon lights, just like auroras, just like plasma. The ground doesn't just crack, it charges, and the sky reacts. This means something unsettling. The Earth may be signaling its failure before it happens, a warning written in light, but the warning is subtle, rare, easy to miss, and terrifying once you understand what it means. Because if the sky can glow before an earthquake, how many times has it happened when no one was looking? The idea that rocks can generate electricity sounds impossible. But physics disagrees. Certain minerals, and especially those containing quartz, are piezoelectric. That means when mechanical stress is applied, they produce an electrical charge. The same principle is used in watches, microphones, and sensors. Now imagine this effect on a continental scale. Tectonic plates grinding against each other. Millions of tons of rock under pressure. Stress building for decades or centuries. As strain accumulates, microscopic fractures form inside the rock. These fractures allow electrical charges to move. Not fast, not violently, but persistently. Scientists believe that before some earthquakes, the crust becomes electrically unstable. Charges migrate upward. When they reach the surface, they interact with the atmosphere. This interaction can produce light in multiple forms. Glowing orbs, vertical columns of light, flash-like bursts, wide luminous clouds, pulsing glows near fault lines. Different colors appear depending on atmospheric conditions. Blue and violet indicate nitrogen excitation. Green can come from oxygen. White flashes occur when ionization is intense. In some cases, the light originates near the ground. In others, it spreads across the sky. But the mechanism remains the same. Stressed rock releasing energy into air. What makes this more disturbing is timing. Earthquake lights don't always appear during shaking. Sometimes they appear hours or days before. That suggests the crust begins electrically failing before it mechanically fails. The Earth doesn't snap suddenly. It weakens, it leaks, and that leak sometimes becomes visible. This raises a dangerous question. If earthquake lights are real and predictive, why can't we use them to warn people? The answer is uncomfortable. Because the phenomenon is unreliable. Not every earthquake produces lights. Not every fault behaves the same way. The geology must be precise. The stress must align. The atmospheric conditions must cooperate. And even when lights appear, they are often dismissed, mistaken for transformers exploding, power grid failures, weather anomalies. In some cases, they are only recognized afterward, when footage is reviewed. By then, the damage is already done. Another disturbing detail. Animals appear to react before humans do. Before major earthquakes, reports often include strange animal behavior. Dogs howling, birds fleeing, livestock panicking. One theory suggests animals sense electrical changes in the air or ground. If the Earth becomes electrically charged, sensitive nervous systems might detect it. Humans, dulled by concrete and insulation, remain unaware. The sky glows, animals react, people sleep, until the ground moves. Earthquake lights don't scream, they whisper. And whispers are easy to ignore. But once you know what you're seeing, a glowing horizon is no longer beautiful. It's a warning sign written in physics, and it reminds us of something unsettling. The planet we live on is not inert. It is active, responsive, charged, and when it reaches its limits, it doesn't fail quietly. There is something deeply unsettling about earthquake lights, not because they are mysterious, but because they are understandable. They don't require aliens. They don't require supernatural forces. They require only physics pushed too far. The Earth, under stress, begins to behave like a machine exceeding its tolerances. Electrical systems destabilize. Energy leaks outward. The atmosphere responds. The sky becomes part of the failure. This challenges how we think about disasters. Earthquakes are usually described as sudden, unexpected, instant. But earthquake lights suggest something else. A slow approach to collapse. A buildup of pressure that announces itself. Modern research continues to investigate whether these lights can be used for early detection. Some satellites monitor atmospheric ionization. Others track electromagnetic anomalies near fault zones. There are hints, patterns, possibilities, but nothing reliable enough to save lives yet. And that is the most unsettling part. The signals may be there, but we don't know how to read them. Or worse, we see them and dismiss them. In 2008, days before a major earthquake in China, residents reported strange lights in the sky. The warnings were ignored. Tens of thousands died. In hindsight, the signs feel obvious. In the moment, they were meaningless. This is the nature of subtle disasters. They announce themselves quietly, they don't demand attention. They offer clues instead. And humanity has never been good at listening to whispers. Earthquake lights remind us that the boundary between solid ground and open sky is thinner than we think. Energy moves through it. Stress crosses it. Failure reveals itself through it. The planet is not just beneath us, it surrounds us. When tectonic stress reaches a breaking point, the atmosphere becomes part of the event. The sky participates, and for a brief moment, the Earth reveals what it's about to do. Then gravity takes over. Structures fail, lives change, the lights fade. And afterward, people ask the same question. Why didn't we know? The answer may be harder to accept than ignorance. Because sometimes, we did know, we just didn't understand what we were seeing. Before the ground breaks, the sky can glow. And once you know that, you will never look at strange lights the same way again. If you're fascinated by unsettling science, real-world mysteries, and the hidden signals of our planet, subscribe to Dark Science Files for weekly investigations.